Welcome to the GEOS 1701 Finding Your Way with Maps pre-lab material. This is part 4 of the pre-lab videos, and in this video we're going to deal with the differences between using paper maps or topographic maps for giving coordinates and navigation versus using GPS systems. We saw in a previous video we introduced the concept of the geographic graticule. Now, the graticule is the network of parallels of latitudes and meridians of longitude that tell us distances in arc, angles of arc, either north or south of the equator for the parallels of latitude, or east or west of some prime meridian. And we typically have used the Greenwich meridian since the early 20th century. Now, as part of that, we're also familiar with some of the main parallels of latitude, such as the tropics, the Arctic circles, and the equator as well. And so we've dealt with these in our climatic studies. But we saw how we could give lines of latitude or give coordinates of a place in values of latitude and longitude. In a previous video, we also dealt with the Australian map grid and how we could use that also as a navigation tool and a way of defining the coordinates for a certain location on the Earth's surface. Here, using a grid system, we gave the coordinates as actual distances from some false origin or starting point of the grid. So rather than degrees of arc around the spherical shape that we're using to define the Earth, we're instead using them as distances along some flat plane similar to Cartesian geometry. Now, we also saw as part of this, as of using those different systems of navigation and different ways of defining a location of a place, that gave us also different definitions of north. And we saw the difference between a true north, which is where the meridians of longitude converge at the North Pole, so the true north points towards that, and also the grid north, which follows the grid lines on a topographic map. Finally, we also saw that we could use magnetic north, which tells us where the magnetic North Pole is and where our compass needle would point towards. Now, we saw that as part of this, there will be differences in terms of the values we've got and some issues of grid convergence between using the grid versus the graticule. And we noticed that there was a difference between the orientation of the lines in the borders of our map sheet, because the map sheet itself was aligned relative to the graticule, and the borders of the map sheet are defined as lines of latitude or longitude, whereas the grid lines are what we're using to actually work out where we are on the actual map sheet and give our coordinates. So there was a slight difference between the grid and graticule there, and that often had to be taken into account as part of how we use the maps and interpret the maps. Similarly, there's a difference between using paper maps and also using GPS as our way of navigation. Now, 20 years ago, hardly anyone used a GPS system except the military. But now, almost everyone navigates via a GPS, and paper maps are much less popular. Indeed, most people probably haven't bought a paper street directory for decades, but almost every car these days has a GPS in it, or people use their phones and the GPS in their phones to navigate their way around. So how do we get different values from a GPS versus what we're getting out of using a simple paper map? Well, we discussed a little bit of this before, in that we had to change our map grid. We had to go from the Australian map grid to the map grid of Australia, and so that meant we had slight differences in the actual eastings and northings between different versions of those grids. If we think about how a GPS works as well, it's actually quite precise in the way it gives the location. When your car GPS system says turn left now, or this is your street coming up in 50 meters, it's typically within the urban areas quite accurate. And the GPS location, which is differential GPS, because it relies upon mobile phone base stations as well as the satellites, really allows us to navigate to the nearest meter. So the coordinates that we get off our GPS system, if we actually use it to give a location and not just tell it to direct us to somewhere, are actually distances to the nearest meter. And remember that all grid coordinates are also distances. but we've only typically been using them up till now to the nearest kilometre or the nearest 100 metres. So a GPS system reports the full distance, by that we mean to the nearest metre from the false origin of the grid, and it doesn't truncate any of that information. So it will tell you that in thousands or millions of metres. So we can see on our typical paper map, we have grid lines here. And so the northings here are numbered here as we go up the page, and the eastings along the bottom, and those grid lines are 1 kilometre apart. We also saw in a previous video that in front of some of those grid numbers, so the numbers that are used here to actually label our grid lines, we've been mostly dealing with the larger numbers, the bolder or larger numbers, but in front of some of them there's a smaller superscripted number, and this smaller superscripted number also really needs to be included. We've been ignoring it because we've been working mostly off the one map sheet, but now if we're thinking about true locations using a GPS, this information all needs to be included. So rather than just to refer to these grid lines in terms of the easting example, here is 0, 9, 10, 11, 12, etc. They should be 309, 310, 311. Similarly, the northings here, instead of being just 85, 86, 87, should be 6,185, 6,186, and so forth. And those numbers are kilometres. So that really should be 6,185 kilometres north of the starting grid, the false origin starting point of the grid. Similarly, the number here is 310 kilometres east of the false origin starting point of this part of the Australian map grid. So let's look at an example, and let's have a look at Bass Islet that's shown here. So it's one of the many little islands or islets off the Port Kembla Harbour, just to the south of Wollongong here. And the standard grid reference we would have used in our labs would have been, again, just using the larger numbers that we see on the side of the mapping sheet here. So we could work out that this was 3/10 of the way between 11, the easting 11 and easting 12, so we'll call that 113. Similarly, we could work out it was 4/10 of the way between northing 84 and northing 85, so we'll call that 844. Remember, we didn't show the decimal places. Well, that's fine if we're working on that map, and it's just that's what we call a standard 6-figure grid reference, and it serves our purposes quite well for that simple navigation task on that particular map. But if we want to use the full distance or provide the full distance in kilometres, we need to actually include those superscripted values as well. So that distance or that coordinate or that grid reference now, they're all the same thing. As an easting will be 3,113. That's actually saying 311.3. We'll come to that in a moment, but let's leave it in the format we've had it. So we're just putting the 3 in front of the number we had previously. And also for the 844 that we showed up here, we're actually putting the 61 back in front of it. So now we've included the entire distances in kilometres that we can obtain from the information on the map sheet. Now, again, we know where that place is, and so that still narrows us into the same place, but all we've still done is interpolate there to the nearest 100 metres. For a GPS system, we need to interpolate past that and actually break this down, each of these kilometre sections, down in thousands a thousandth rather than a tenth, which gets us to the nearest metre, not the nearest 100 metres. So where we've gone 311.3, we've actually got to add 2 more zeros to get down to that metre scale accuracy. And similarly here for the northing, again where we had 61844, if we put 2 zeros on the end, that goes from the nearest 100 metres to the nearest 10 to the nearest whole metre. So that becomes the true grid reference, the full grid reference we would show in a GPS system. That we also need to include the zone of the Australian map grid from which this was obtained. And so we're actually in zone 56H, and we'll cover that in the labs in a bit more detail. But at the moment, just appreciate a full grid reference of a GPS system actually has all these extra numbers. We've only dealt with the 3 tucked away in the middle here, but we should include all of that as part of using our GPS systems. Now, if you look at a map, and so a 1 to 25,000 map, and this is the top right-hand corner of the Bulleye 1 to 25,000 map that we'll use in our lab classes this week. And indeed, there, the actual last easting and the last northing before we get to the corner of the map sheet are fully labelled, just like a GPS would label them. So again, 13, 14, 15 are the large numbers of the eastings. 6, 7 and 8, ignore this 7 for the moment. 6, 7 and 8 are the large numbers for the northings. So again, what they do is we will add in that 3 that we've been ignoring before, and also break that down to the nearest 1,000th. So we put 3 zeros on the end. So it's telling us that this particular easting is actually not 15 kilometres or even 315 kilometres east of a starting point. It's 315,000 m for metres east of the starting point. Similarly, this northing is 6,208,000 metres north of the starting point. So that implies our metre scale accuracy, which is what the GPS systems give us. So if you can't read those numbers there, we'll just zoom in on those a little bit and show them here. As I said, that's the same section, just blown up a bit more. And we can read 315,000 metres east here for the last easting, and 6,208,000 metres north for the last northing. So you can now see how GPS coordinates relate to the coordinates we've been giving on the map systems. Remember, that's different to the latitude and longitude, which are also shown on the map as well. So all these systems can be mixed from one to the other if we need to. Okay, that ends part 4 of this pre-lab material. Hopefully it's clarified for you some aspect of using GPS versus paper maps for coordinate systems. Okay, good luck.